Hello children, today we are going to discuss the basics of chapter 2, electrostatic potential and capacitance. We will be seeing few definitions and few terms that are used throughout in this chapter as well as in the upcoming chapters. You all know what is an electric charge, right? So when we describe charge, we will describe a charge and there will be a region in which the field can be experienced. So this is the region surrounding the charge which is called as the electric field. Okay. So electric field around a charge can be described in two ways. By the first way is by expressing the field strength, electric field, how much, how close, how intense the field is. And as it goes far away, the field becomes weaker. We have discussed earlier regarding this. The new term is electrostatic potential. So the name very clearly says that there is a potential due to the static nature of this charge. So now we can see a charge Q here. Let us assume this as a positive charge. Okay. So now we are bringing a test charge. You know the definition for test charge. It is a negligible charge. It does not disturb the orientation or the character of the source charge. Okay. Now we are introducing a test charge. Let us assume that the test charge is also positive. Okay, at this region, we say that there is no field, no electric field. That is the field due to this charge, this capital Q. There is no field due to this charge in this region where the test charge is placed. So now we are slowly moving this test charge. And as soon as this test charge reaches the region of the where the field of the source charge is available, what will happen? This test charge will be repelled away, right? There will be a force of repulsion that this test charge will experience because of the field of the source charge. So this force is called the potential and it is due to the source charge. Okay. So, but I want to place this charge, test charge here at this point. Okay. Let me say this point is A. So, what should I do? I should exert a greater force than the force of repulsion that is available in this point, right? My force that is applied to this test charge should be greater than the force of repulsion that is present here, so that I am able to safely place this charge here, test charge Q here. Okay, so now plus Q is placed here. Then for placing plus Q here, we are exerting a opposite force to this electric field. Okay. So this is the force experienced by the test charge is called electrostatic potential. So now the same thing we will explain with different kinds of charges. So now you can see a negative charge. Okay, the source charge is a negative charge. Q is minus. Now you can see a plus charge. This is the imaginary test charge. Okay. So now the energy in ideal case, what will happen? This test charge will be attracted by this negative plate or this negative charge. So it will have very less opposition. It will have attraction, right? So that is why we write less. But I want my test charge to be in this place. This imaginary charge, I want it to be in this place only. I don't want it to go to like the negative plate and get attracted towards it. I don't want this positive charge to stick to the negative place. I want it to be here. So what should I do? I should exert energy in the opposite direction to the pull of the negative charge such that this imaginary test charge stays in this place. That energy is stored in the form of potential energy. Okay. So energy in the stored form is called potential energy. So now like I want the test charge. If I want the test charge to be here, this imaginary charge, will the potential energy be same in both cases? No. If this is point A and this is point B, the potential energy at point A will be UA and the potential energy at point B will be UB. So the difference in potential energy will be UA minus UB or UB minus UA. Okay, both you can take based upon the where the potential energy is greater. So I hope now you have a clear idea of what is electrostatic potential, how it is generated, and how do we move a test charge or place a test charge at a particular point, overcoming the force of the source charge. Okay. So same case, here it is positive, plate and positive test charge. So now what happens in regular case, this positive plate will repel this positive charge outside, right? So it will be pushed outside. But if I want to stay here, what I should do? I should give a force in the opposite direction to this repulsion. Okay. So what happens? The potential energy at this point, as it is in the outer electric field, here it will be less. And if I bring it here, what happens? UB will be greater than UA. So as we go closer, if you wanted to push this test charge closer to the plate, positive plate, you have to apply extra energy such that it is pushed towards the desired location. So these two diagrams, I hope, will give you a clear picture of what is electrostatic potential. Okay, so now we will see the definition of potential difference. Okay, so now I told you earlier. So now this region has a potential energy and this region has a different potential energy. So if I need to bring this test charge to somewhere inside, I need to apply some force, right? And my object is, my test charge is displacing. You know that work done is equal to force into displacement. Okay. So I'm applying a force and the test charge is displaced by a distance of ds or whatever it may be. So potential difference between 2 points in an electric field may be defined as the amount of work done in moving a unit positive charge. Unit positive charge means the test charge from one point to another against the electrostatic forces. What is electrostatic force here? The force that is produced due to the field of the source charge. Okay. So potential difference can be defined as work done per unit charge. Okay, that is why work done by charge you can write. Okay. So now, what is the SI unit of potential difference? You all know it is volt, right? So 1 volt will be equal to, here you can see here, potential difference definition is work done by charge. What is the SI unit of work done? Joule, right? So joule per coulomb. Now, another formula, work done is equal to force into displacement, right? So force is Newton, displacement is meter. So Newton meter per coulomb. All these are SI units of potential difference. So now potential difference, if you write it in mathematical terms, if you can write it this way, V is equal to VB minus VA, which will be equal to WAB divided by Q. So what is this VB? Potential at B, and VA is the potential at A. So this is taken when the potential at B is greater than the potential at A. So see here, if this is VB, this is point B. So when the potential at this point is VB, here it is VA. So potential difference means VB minus VA. Okay, divided by, that is equal to what done by the charge. So now with this, let us define 1 volt. So we already saw that 1 volt is equal to like 1 joule per 1 coulomb. So usually for writing the definitions of quantities like this, be it coulomb or ampere or whatever it may be, write the SI units. So here volt is equal to joule per coulomb. Now substitute 1 in each case. Okay. So 1 volt is the potential difference between 2 points in an electric field if 1 joule of work has to be done in moving a charge of 1 coulomb from one point to another against the electrostatic forces. So 1 volt, again I repeat, potential difference between 2 points in an electric field is said to be 1 volt when you do a work of 1 joule to move a charge of 1 coulomb from one point to another against the electrostatic forces. Okay. So now, what is potential at a point? So we'll take the same diagram. Okay. So this is the field. Okay. So now there is a test charge. I'm moving the test charge here. When I bring here, what happens? Repulsive force is experienced. So slowly I wanted this point. So slowly I am pushing it. I'm applying an extra force and bringing it here. Okay, this point. So now there is a potential at this point, right? There is a force experienced at this point. Okay, so we have to apply extra force to overcome the force that is present in that point. So this is called, the potential available at this point is called electric potential at a point. Okay, so electric potential at a point in the electric field is defined as the work done in moving a unit positive charge from infinity. Infinity means from an unknown distance where the source charge field is not experienced. Okay. So against the electrostatic force. So the work done to move this test charge to the point P is called the electric potential. So now if I wanted to still move it to some other point, say K. So now this point has a potential Vp, this point has a potential Vk. So the difference between these two is called potential difference. Okay. So I hope the definitions of what is electrostatic potential, potential difference, volt, and the notion of electric potential is understood. If you have any doubts, you can raise in the comment section. We will be happy to help you. Thank you.